In the previous video, we built a simple classifier to arrange the random data provided by us. This talks about building a logistic regression classifier. We will use it to draw linear boundaries between our classes and extract these boundaries by solving a set of equations derived from the training data. Let's see how to do this in Python. We'll use the logistic_regression.py file that is provided to you as a reference. Assuming that you imported the necessary packages, let's create some sample data along with training labels. So with this code we have created the training data, and these are the assigning labels to this data. Here we assume that we have 3 classes. Now let's initialize the logistic regression classifier. So you can see we have used this syntax to initialize it. There are a number of input parameters that can be specified for the preceding function, but a couple of important ones are solver and C. The solver parameter specifies the type of solver that the algorithm will use to solve the system of equations. The C parameter controls the regularization strength. A lower value indicates higher regularization strength. So let's train the classifier by adding this code. Next we draw data points and boundaries. After this we need to define plot classifier function, so let's define it. And this is the code for our plot classifier function. Let's understand the logic line by line. These preceding values indicate the range of values that we want to use in our figure. The values usually range from the minimum value to the maximum value present in our data. Here we also add some buffers such as 1.0 in the preceding lines for clarity. Now, in order to plot the boundaries, we need to evaluate the function across a grid of points and plot it. So let's go ahead and define our grid. So, this is our grid. The x values and y values variables contain the grid of points where the function will be evaluated. Let's compute the output of the classifier for all these points. So, now you can see that we have computed the classifier output and reshaped the array. Let's plot the boundaries using coloured regions. This is basically a 3D plotter that takes 2D points and the associated values to draw different regions using a colour scheme. You can find all the colour scheme options at matplotlib.org. Next, let's overlay the training points on the plot. Here, the plot.scatter function plots the points on the 2D graph. x:0 specifies that we should take all the values along axis 0, here in our case is the x-axis, and x:1 specifies axis 1, which is the y-axis here. The c=y parameter indicates the colour sequence. We use the target labels to map to colours using CMap. Basically, we want different colours that are based on the target labels. Hence, we use y as the mapping. The limits of the display figure are set using plot.xlim and plot.ylim. In order to mark the axis with values, we need to use plot.xticks and plot.yticks. These functions mark the axis with the values so that it's easier for us to see where the points are located. In the preceding code, we want the ticks to lie between the minimum and maximum values with a buffer of 1 unit. Also, we want these ticks to be integers, so we use the integer function to round off the values. So now let's run this code and see the output. So let's move on to our command prompt and type the file name. Now you can see the resulting figure for our code. Let's see how the C parameter affects our model. The C parameter indicates the penalty for misclassification. Let's go back to the editor. Now if we set it to 1.0 and run our code again, we get this output for C equals 1.0. Next, if we go ahead and set C to 1000, we get this output. Here you should note that as we increase C, there is a higher penalty for misclassification. Hence the boundaries get more optimal. In this video we saw how to build a model that can draw linear boundaries between classes for a given set of data points. In the next video, we'll take a look at the use of Bayes' theorem to build a naive Bayes classifier.